Hello everyone, welcome to this session. In this session, I'm going to explain about the properties of fluids. For the study of the fluids, the different types of fluid flows, and energy transfer from the fluids conversion that we are going to study if we know the fluid properties. Some of the important fluid properties I'm going to discuss here, and those properties are shown here. And these properties with the definition and about that I am going to discuss. Firstly, the first and foremost very important definition of the any substance, not only the fluid, any substance. It may be a fluid, it may be solid, or it may be anything. The first definition is its density. Okay, that density that is also called as a mass density or specific mass. Density of the substance, we should know the first and later we'll move further. The density of the fluid, concerned to fluid, we are going to take this definition. The density of fluid is the ratio of mass to volume of substance. It is denoted by rho and its unit is kg per meter cube, mass per volume. Okay, then moving further, it is expressed as a rho equal to m by v. And next definition is that specific volume. The specific volume is the volume occupied by unit mass of the substance. Okay, for one unit mass of the substance, how much volume it occupies? If it is a liquid, how much volume it takes? If it is a gas, how much volume it takes for unit mass? Okay, that volume, whatever is there, it is called as a specific volume. Or another definition, volume per unit mass of the substance will call as a specific volume. It is denoted by V. Its unit is meter cube per kg and it is reciprocal of density. Density is mass per volume and specific volume is volume per mass. Then it is a reciprocal of density. That we can take, that is V equal to 1 by rho. Okay, then that is equal to V by M. Okay, then volume per mass. Okay, then here if you know the density, the specific volume of that substance also we can find out. Then moving further, next definition is that specific weight or weight density. Specific weight or a weight density. It is specific weight or weight density, not of this one. It is the ratio of weight of the fluid to the volume of the fluid. Okay, that is mass of the fluid to the volume of the fluid is mass density, and weight of the fluid to the volume of the fluid is the weight density. Okay, that is given as rho W, that is a weight density, is weight per volume. Its unit is Newton per meter cube. Weight is taken in terms of the Newton. Then moving further, the next important definition is that specific gravity. Usually the specific gravity of the all the fluids are given. For example, if you take that one, if you go to the petrol pump, the specific gravity of the petrol is usually mentioned 0.78 or something. Okay, then density it will become say 780. And what is that specific gravity? The specific gravity, it is the ratio of the density or weight density of the fluid to the density or weight density of the standard fluid. It is denoted by S. It is the density or weight density of the fluid to the density of or weight density of the standard fluid. Okay, then that we can write as S equal to density or weight density of the fluid to the density or weight density of the standard fluid. And here, what is the standard fluid? That we should know. And for the liquids, the standard fluid is different. For gases, the standard fluid is different. For liquids, water is the standard fluid, and for gases, air is the standard fluid. Okay, liquid standard fluid, we are going to take water. Gases, we are going to take air as a standard fluid. Then the density of water is 1000 kg per meter cube. The density of water is 1000 kg per meter cube, and specific gravity is 1. Specific gravity of the water is 1. Then in the denominator, this we are going to take always 1000, and numerator, whatever is the particular fluid density we are going to take, that ratio will give the specific gravity. The next definition is the viscosity or dynamic viscosity. The viscosity is important property concerned to the when fluid is flowing. When fluid is flowing, then the viscosity plays very important role. How it is that one? What is it? It is the resistance offered by the one layer of the fluid to the another adjacent layer of the fluid. It is denoted by mu, and its unit is Newton second per meter square. Okay, if the fluid is moving within the fluid itself, the one layer and another layer, the resistance offers. If the resistance is higher, the viscosity will say higher. If the resistance is lower, viscosity is lower. And this, if the higher is the viscosity, then there is a resistance for the flow of the fluid, then the flowing will not be smooth. The flow of the fluid is not smooth, and that requires more force for the movement of the fluid. The more pressure we have to apply. The pump pressure should increase for that. That consideration is there. And this viscosity also taken into consideration while taking the lubricants. The lubricants, what are there? Those are should have the higher viscosity. Okay, for example, lubricants, what we have taken, the oils which are going to use where the moving surfaces are there. And there the usually higher viscosity fluids we are going to use. Those are called as lubricating oils. Okay, that is about the viscosity. And this viscosity is also given by the another type of viscosity that is called as a kinematic viscosity. It is the ratio of dynamic viscosity to the density of the fluid. It is denoted by nu, and its unit is meter square per second. And nu is given by mu by rho. Okay, dynamic viscosity to the density of the fluid. Next definition is that surface tension. For all the fluids on the surface, there is some tensile force is acting, and that tensile force, whatever we are going to call, that is the surface tension, the tension offered at the surface of the fluid. It is a tensile force acting on the surface of the fluid or surface between two immiscible fluids. Okay, if there are two immiscible fluids, for example, if you take the oil and water together, if you take, there is a separation layer between them, and at that layer also there is a tensile force is acting, and that is also we'll call as a surface tension, and it is denoted by sigma, and its unit is Newton per meter, the force per its distance. Okay, this tension means this also we need to take into consideration for the fluids. Next density is the capillarity. Capillarity is the phenomena of rise and fall of the liquid in a small tube compared to the outside general level of fluid. When tube is held vertically in a fluid. When the fluid tube is held vertically in a fluid, then the fluid will be rises in the tube or falls in the tube, the level whatever is there. If the rise of the fluid is there, we'll call as a capillary rise. If the fall is there, we'll call as a capillary fall. And here, usually it is expressed in terms of the millimeter of the fluid. Okay, that is the distance for which it will be rising or falling. And capillary rise, whenever if you want to take that one, if you insert the small tube in a water, the water level in the tube will be rises. And the capillary rise is there for the water. If you insert the small tube in a mercury, its level will be reduces. For the mercury, the capillary fall will be taking place. And that is the one of the phenomena which is considered as the property of the fluids. Moving further, next one is the vapor pressure. This vapor pressure means the whatever the above the liquid, if the vapor is formed, if the vapor of the fluid is formed, then the pressure applied by that vapor on the fluid, that is called as a vapor pressure. The vapor pressure of the liquid is the equilibrium pressure of a vapor above its liquid. Liquid, whatever is there above that one, whatever the vapor is there, okay, that pressure will call as a vapor pressure. The vapor pressure of liquid varies with a temperature. With temperature, that will be varies. As the temperature increases, vapor pressure also increases. As the temperature increases, the vaporized fluid will be more. The steam of the fluid will be more. Then the pressure will be increases as the temperature increases. Moving further, the last property is that it is a cavitation. Cavitation is the one of the property, or it is a phenomenon which will considered in where the fluid flow is taking place. For example, in the turbines, pumps, fans, blowers, there this phenomenon occurs. What is that phenomenon? It is a phenomenon of formation of the vapor bubbles within a liquid at low pressure regions that occur in places and where the liquid has been accelerated to a high velocities, as in the operation of centrifugal pumps, water turbines and marine and collapsing at high pressure region. And whenever the suddenly velocity increases, the pressure reduces. The pressure energy is converted into kinetic energy. And due to the low pressure, the vapor bubbles are formed because at a lower pressure, at low temperature itself, the vaporization will be taking place. And due to that, the vapor bubbles will be formed within the flowing fluid, and that will be there on the surfaces of the some of the equipments like pumps and turbines, marine engines like that. And later, whenever this bubbles are carrying further and reaching to the that high pressure region, those will be get collapses, and that is there is a effect of this cavitation. Wherever the bubbles are collapses, the pitching of the surface will be taking place. That pitching means the surface will be get damaged, and that is the reason the cavitation phenomenon should not occur. That care should be taken for the operation of these machines. And what is the reason is that will not should not get damage any of the surfaces of the machines. And these are the some of the important properties of the fluids. Thanks for watching. If you like, share, subscribe, and comment.